the first type of partial fraction is for distinct linear factor. So you have 2x plus 3 over x plus 1, x minus 1, right? Okay, so for this one, you see the factors, right, are linear. Linear meaning is a power. You see, it's like power 1. And they are distinct. Distinct means different.
Yeah.
Distinct, different. Okay, so with that, right, the case, right, is we put it in this way. A over x plus 1 plus b over x minus 1. Okay? Second case is example. This is what we call distinct linear factor. Just give me about 5 minutes. I'll explain very fast. Distinct linear factor. Distinct means different. Linear means power 1.
Yeah.
Okay, but the next one is maybe so-called non-distinct. Non-distinct, how to find? Non-distinct linear factor example looks something like that. 2x plus 3. One of them is x plus 1 square. The other one is x minus 1. Okay, so
it's
what
x plus 1 square and x plus 1 and
yes,
x minus
correct.
1.
So we repeat the one that's being so-called this, right? We must repeat this. We must repeat this part. Okay, we repeat this. Okay, so we have x plus 1 plus b over x plus 1 square plus c over
x minus 1.
yes, correct. Okay, next one is if is what we call a quadratic factor. Quadratic factor, it really means that your factor is power 2.
Okay.
Quadratic power 2. So example like that, 2x plus 3 x square plus 2. Okay, so you stress that this quadratic factor has to be non-factorizable. It has to be non-factorizable. If it's factorizable, then no count. Okay, so some you see a later on, I'll show you like that. Okay, so what we do is for this, how do you write out how do you break out or decompose the partial fraction?
So 2x
with
over
reference to this one, right?
Yeah.
Correct. How we break it down is we write a x plus b over x square plus 2. Because if you divide by x square plus 2, you will get a linear, you may get linear plus c over x minus 1. So I stress one thing is that this one, right, it is non-factorizable. This one must be non-factorizable. What do I mean by factorizable? Okay, example, something like that. Example, if I put 1 over can I say this is ax plus b?
No, x minus 2x
plus 2. Correct. So this is x minus 2x plus 2. So we must write it as a plus x minus 2 b over x plus 2. Okay, so this is not the same as case 3. Okay,
Yeah.
Okay, then quick, how do we solve this? Simple. Okay, so let's say I just look at this. How to solve this? Quick one. Okay, basically just like that. 2x minus 3 over x minus 1 x plus 1. Easy one, very easy one. It's so very logical. The idea is we want to find a and b correct. So to find a and b, we go back to what we know. This is a topic on polynomial. So we want to create a polynomial. So let's just create a polynomial. What I'm going to do from here to here, I just multiply everybody by x minus 1, x plus 1. So I'm going to multiply this by x minus 1, x plus 1. I multiply this one, x 1. So the whole village multiply. So this one I multiply, this one cancel off. This one I multiply this and this cancel off, I get a bracket x plus 1. This one multiply this and this cancel off, I get b x minus 1. From here, okay, settle it. Just sub x equals to 1, find a. Sub x minus 1, find b. So example, let x equals to 1. Left hand side 2 bracket 1 minus 3. Right hand side, this one become 0. You have 2a. 2a equals to negative 1, a equals to negative half. Then after that, let x equals to
equals to negative 1.
Yes, you sub things to make it disappear. Sub negative 1, then 2 negative 1 minus 3 equals to a 2a plus a x plus 1. So this will disappear. Then you left with b negative 2 negative 2b equals to negative 5. B equals to 5 over 2.
Okay,
Okay, can